let's talk about the GCSE model of the atom. At GCSE, we use the Bohr-Chadwick model. So I'm crediting this to two scientists, and that's because Chadwick is the one that discovered the neutron, and Bohr is the one that told us about how our electrons are going to be arranged. Now, any of you that are going further to study A-level chemistry, you might throw this model in the bin soon. But for now, this is going to be the key to unlocking your GCSE atom success. So let's figure out what our atom is made up of. And even though an atom we consider the smallest indivisible unit of matter, there are subatomic particles, okay? So if we first split our atom up into the two main sections, in the center of the atom, we have got the nucleus. And then orbiting the atom, pretend that these are way far out, okay? Then we have got the electron shells. In each of these parts of the atom, we can find different subatomic particles. So let's start with the nucleus first, so the middle of the atom. You'll see that I've got two different types of particles identified. So we've got the ones with the positive charge. So those are called the protons. Okay, again, protons have got a charge of +1 or 1+. And we also say that they have a relative mass of, how can I write this? Relative mass of 1, okay? Again, the reason that we call it a relative mass is because, as you'll know, atoms are tiny, they're beyond tiny. So really the mass of a proton is 1 × 10 to the minus something ridiculous. But to make it easy to compare our different subatomic particles against each other, we just say they have a relative mass of 1. So when we're comparing them against each other. The other subatomic particle within the nucleus, so these ones that I've left blank, those are the neutrons. Can I spell neutrons? That's the first hurdle. Neutrons. Now, as the name suggests, neutrons are neutral, so they have a charge of 0. But just like the protons, they also have a relative mass of 1. Okay, so protons and neutrons have the same mass, and that's why the nucleus makes up all of the mass of an atom. Now, outside of the nucleus, so surrounding it in what we call shells, that's where we have our electrons. Electrons, you can't quite see because of how they're drawn here, but they have a negative charge. So specifically, we say that they have a charge of 1- or -1. And for their relative mass, electrons are barely particles. They're kind of clouds and particles at the same time. Their mass is negligible. So we can say that their mass is approximately 0, or if you want to be a little bit more precise, you can say 1/1840. Okay. Again, the mass is so tiny that when we're considering the mass of an atom, we don't think about the electrons at all. We just think about the protons and the neutrons with their relative masses of 1. Okay, so how does this model link to our atomic notation? How do we know for each element in the periodic table how many protons, how many neutrons, and how many electrons there are? So let's move over here. I'm going to stick with this element. This is lithium, and I know that from the number of protons. So lithium, that's our symbol. And then we would write the notation with a 3 on the bottom and a 7 up at the top. So let's talk about what these two numbers mean. The 3 corresponds to the number of protons in the nucleus. So the number of protons. And the name that we give the number of protons is the atomic number. The atomic number defines which element we have. So every single element on the periodic table has a different atomic number, a different number of protons, which is how we know which element we're dealing with. Then if we look at the number at the top, 7, and again, if we relate it back to our diagram, you can hopefully spot that there are 7 subatomic particles within the nucleus, or 7 nucleons if you want to be fancy and if you're a physicist as well. So 7 nucleons. So 7 corresponds to the number of protons plus the number of neutrons. And the name that we give this is the mass number. Okay, again, this helps us to link back together what we already know about the relative masses of protons and neutrons. All of the mass of an atom is concentrated in the nucleus. So when we're considering the mass number, that's only taking into account the protons and the neutrons, not the electrons, because their relative mass is approximately 0. So now we've got the number of protons. We don't quite have the number of neutrons by itself, but if we have the number of protons and neutrons in the mass number, then if we want to calculate the number of neutrons, then all we need to do is take our mass number, which is protons plus neutrons, and subtract the atomic number, which is just protons. Okay, that gives us the number of neutrons. Now, how do we figure out how many electrons we have in an atom? The key here is, and again, coming back to our diagram, an atom overall is neutral. So an atom has no charge. That means that our positive protons and our negative electrons need to cancel out. Okay, so however many protons we have, which we already figured out from the atomic number, we must have the same number of electrons so that the charges cancel and the atom is neutral overall. So the number of protons is going to be equal to, and we're going to have to bend down maybe a little bit, the number of electrons in a neutral atom is going to be equal to the number of protons. So let's link this back again to our lithium. So let's figure out how many protons, how many neutrons, and how many electrons. Number of protons, again, atomic number, so that's 3. Number of neutrons, that's the mass number minus the atomic number, so 7 minus 3 to give us 4. And then the number of electrons, same as the number of protons, so that our atom is neutral overall. Which means that our number of electrons, same as the number of protons, must be 3 as well. Okay, to find out more about why I've put these 3 electrons in this particular configuration, so not all 3 of them on the same shell, make sure that you have subscribed so that you can see that video when it comes, and make sure to like this video and comment with any particular topics that you want me to go through next.